In high-density AI systems, cooling performance depends on one critical factor: stable flow at the chip. System pressures vary as operating conditions change, but traditional fixed restrictors, such as an orifice, tie flow directly to pressure, which means as pressure changes, flow becomes unpredictable, leading to uneven cooling and reduced performance. In this demonstration, we compare a fixed restrictor to Lee's flow regulating valve across a range of pressures. The setup includes two parallel flow paths, each with controlled pressure input and real-time flow measurement. At low pressure, the flow regulating valve quickly reaches its set flow rate, while the fixed restrictor underdelivers. As pressure increases to 5 psi, both components reach the 0.5 liters per minute flow. Then, as pressure increases further, the restrictor flow rate continues to rise, while the flow regulating valve holds a constant flow rate. The restrictor flow varies directly with pressure, while the flow regulating valve maintains a constant stable flow rate across the entire operating range. Fixed restriction ties flow to pressure. Lee's valve breaks that dependency. The result is consistent, controlled flow independent of system conditions. In direct-to-chip cooling, this enables improved thermal stability, reduced risk of throttling, and more efficient system operation. Because in modern AI infrastructure, it's not just about delivering flow, it's about delivering the right flow exactly where it's needed.